Hello. Thanks for your interest in Sporian Microsystems' innovative manufacturing and materials for hypersonic thermal protection systems, or TPS. With 25 years' expertise in new technology for the defense industries, Sporian Microsystems actively provides innovative solutions tailored to the needs of the Department of Defense and a variety of other commercial industries. Our strong core competencies and technologies for extreme environments, advanced high-temperature materials, and intelligent sensors have enabled us to push a range of emerging technologies from ideation to production under SBIR funding. Notably, Sporian's development efforts have historically been performed through relationships and partnerships with DoD aerospace prime contractors. These strong relationships and partnerships are ongoing and being leveraged to foster technology development and DoD transition. The extreme speeds and advanced aerodynamic shapes of hypersonic vehicles results in extreme temperatures that can impact the performance and reliability of external structures and internal systems and payloads. These extreme temperatures necessitate the development and use of improved thermal protection systems, and specifically high-temperature operable thermally insulating materials, which are also structurally also known as structural insulators. The availability of such materials will enable optimal tailoring of thermal protection systems for target requirements and thus expand the range of vehicle and mission capabilities. The key for such materials is that they must meet or exceed Navy figures of merit for currently available products, with insulating properties comparable to current products, but with higher strength at temperature. Components made with such materials should be inexpensive to produce and avoid geometrically limiting fabrication processes. Ideally, components made with such materials would be manufactured to near-net shape in applicable component form factors to minimize or remove costly secondary fabrication steps and simplify assembly. While the initial transition target is Navy SSP, such materials have application to a range of wider DoD hypersonic and advanced aerospace vehicles and programs. Improved extreme temperature operable thermal insulation materials and manufacturing processes could be used to realize or replace a range of components for advanced hypersonic thermal protection systems. Sporian's targeted improvements with this technology specifically include providing thermal protection system designers and developers new materials options with both improved thermal and mechanical properties at extreme temperatures, significantly lower cost of critical thermal protection systems components, increase supply chain availability for such materials and components, enable optimal tailoring of the thermal protection systems designed to expand the range of vehicle and mission capabilities, and simplify vehicle assembly, further reducing costs. Sporian offers a class of low thermal diffusivity, insulating materials with ultra-high temperature stability and mechanical strength-to-weight ratio. The materials can operate at up to 1800 degrees Celsius or approximately 3200 degrees Fahrenheit, have strengths an order of magnitude higher, and thermal conductivities up to 25% lower than conventional insulating materials with equivalent densities. The material technology is based on a novel polymer-derived ceramic process that enables the use of flexible manufacturing that can quickly and inexpensively realize near-net shape structures with a range of thermal and mechanical properties. Sporamic's superior thermomechanical properties at extreme temperatures and low cost, flexible manufacturing processes are the key innovations of this technology. At the time of this presentation, Sporian is operating under the base Phase 2 contract. Principal materials and manufacturing process development is complete. The remaining base Phase 2 effort is dedicated to working with DoD hypersonic vehicle prime contractor partners to complete systematic materials testing necessary for DoD and prime contractor stakeholders to perform their technical modeling assessments to identify specific guidance and requirements for DoD platform use and transition planning. As important, the base Phase 2 effort includes work with those same DoD prime contractors to perform manufacturing readiness assessment and identifying needs and milestones for manufacturing readiness level advancement. These DoD prime contractors have been a strong supporter of the proposed technology and this effort, and they have said that TRL advancement cannot and should not outpace MRL advancement. The current envisioned work post Phase 2 would focus on continued partnership with hypersonic systems prime contractors to relevant environment testing of platform-specific components and manufacturing process scale-up. The extreme temperature tolerance and superior insulation properties of Sporian's materials support higher speed and operating temperatures of higher speeds and advanced vehicle aeroshell designs, and thus expands the range of potential vehicle and mission capabilities. Because they are structural insulators with improved strength compared to conventional insulation materials, they can be used to optimize component design, reduce component count, weight, and cost, and again, expand range of vehicle and mission capabilities. The flexible manufacturing process enables faster and cheaper component production and the production of complex geometries and expands the available supply chain for hypersonic system stakeholders. Finally, the ability to produce near-net shape components in applicable component form factors will minimize secondary fabrication steps and simplify vehicle assembly, resulting in reduced component and installation costs and shortened lead times. In addition to continued close coordination with DoD primes and relevant supply chain partners, in order to transition beyond Phase 2, Sporian needs DoD program transition input, either directly or through prime stakeholder partners. This could include technical or program TIC guidance needed to foster transitions. For example, support developing drafts of key performance parameters and key system attributes documentation, or DoD analysis of alternatives. Sporian would also benefit from DoD program guidance or support for relevant environment testing opportunities and defining qualification testing expectations. Currently, Sporian's primary transition advocate is DoD prime contractor Lockheed Martin Space, who would like to engage additional specific DoD program or platform advocates moving forward. Long-term, there are several transition paths for government customer. Sporian can support initial low-volume production and direct sales to primes and the DoD, but for larger scales and longer-term engagements, Sporian would utilize licensing agreements to prime contractors and their supply chain partners and transfer production to approved vendors. To enable transition, Sporian would benefit greatly from input from DoD and prime contractor stakeholder, specifically in regard to defining and meeting MRL and TRL advancement milestones. Sporian is also seeking Phase 3 or LRIP funding mechanisms to support operational environment testing and pilot-scale production. So, as we close out this presentation, we thank you for your interest in Sporian's extreme temperature materials. If you have any questions or are interested in possible collaboration or support, please reach out to Kevin Harsh at Sporian Microsystems. Contact information included here. Thank you for your time. We hope to speak with you soon.